Welcome guys to the best math channel in the world. So your busy made it easy. Today is another series we are going to have on number basis. And this is where we simplify all math topics for everybody to understand. And the last series or the last topic on logarithm is available on my channel. That is finding the true set. Yes, finding the true set, and it is available, which is a topic in further mathematics, also under logarithm. And as promised, today we are going to start our series on number basis. Yes, number basis, as we all know. Yes, number basis used to be in the GHS curriculum, but these days in the mathematics, it's no more. But it's very important to know because it is in the computing and in secondary schools too. Students will also learn it because it's very, very important when it comes to programming and other aspects in mathematics. Now, as we all know, number basis. Now, what we have to understand is that all numbers, the numbers we know, in numbers we have the Roman numerals and we have the decimal numerals. Decimal numerals are in base 10. Yes, what you have to understand, decimal numerals are in base 10. And base 10, the numbers we normally use are from 0 to 9. Yes, all base 10, the numbers we use is 0 to 9. Yes, if you want to obtain any other number, we combine either one or two of these numbers. Yes, so if I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and I want to write 11, then I have to combine two of these numbers. If I want to write maybe 24, I have to combine 2 and 4. If I have 99, and I want to write 100, there's no number I'm going to use again apart from writing 1 here and 2 zeros. This is what you have to understand. So all numbers we write are in the decimal numeral. Yes, are in the decimal numeral. And numbers we have base 2, base 3, base 4, base 5, and many more in writing numbers. So what you have to understand is that in base 2, we have the binary. Yes, base 2 is also known as the binary. And we normally use the binary in computing, which is the 0 and the 1. In base 2, the numbers we use are 0 and 1. In base 2, we don't use 2. That's what we have to understand. So when we start calculating the number basis, you should know the numbers we expect when we are working with any of the numbers. Yes, base 2, we use 0 and 1, which is a binary. We can also have base 3. This is base 2, binary. We can have base 3, which is a ternary, which we use 0, 1, and 2. Yes, we also have base 4, which is the quaternary. Quaternary, for which that one to be used from 0 to 3. Yes, then we have 5, which is the quinary. Base 5, which is the quinary, for which we use 0 to 4. Yes, we have the base 6, which is the senary. Then we have the octal, which is the base 8, and many more. Yes, so this, in case, we normally work with base 2, base 10, that decimal and binary. So this is just a little education that I've given on this. So we have up to base 10. Yes, up to base 10. And what you have to understand, I'm repeating again, if you are working with base 4, the numbers you need is 0 to 3. If you get 4 in base 4, you are wrong. If you get 5 in base 5, you are wrong. If you get 2 in base 2, you are wrong. Yes, if you understand these tricks, I'm sure every number-based question, you'll be able to solve it. And we are going to start our lesson with changing numbers to the decimal number. And now what you have to understand is that, let's say you are working with base 5. If you have maybe 2, 4, 2, base 5. Yes, this number is going to solve in base 5. And this one is called the unit. Unit raised to the power 0. There's no number at the back here, so unit. So that is why any number raised to the power 1, 0 is 1. Anything in unit means 1. So this one, 5 raised to the power 1, because there's one number after this number. So which is 5. So you are going to multiply this number by 5 raised to the power 1. And when you come here, it's 5 raised to the power 2. There is two numbers, or there are two numbers here. So you are going to multiply this one by 5 raised to the power 2. So normally they will tell you when you are calculating, right? Multiply this 2 times 5 raised to the power this. This is the meaning, and this is the reason why. You're working with base 5. This one, you multiply 2 by 5 raised to the power 0. Well, this one is in units. Yes, this one is in units. Then you come here, 1. Yes, so you multiply it by 5 raised to the power 1. Well, there's one number, 5 raised to the power 2. There's two numbers. And when you move on, you count the numbers at the right side, raised to the power, then you simplify them, then you solve. Yeah, that's what you need to understand. So this is the brief introduction on the number basis that I can give. So we are going to start with changing from other bases to base 10, which is the mother base we all know. So we are quickly going to start solving questions on that. So as the first question is posted on the screen, we have to convert 10111 base 2 to base 10. If you don't get base 10, they will tell you convert it to the decimal base. So this one, we don't say 10,111. We pronounce the figures 111. Yes, because we are working with base 10. Yes, and what we have to understand is that in base 10, the numbers we need, the answers we are expecting are from 0 to 9. Yes, and the easy way I normally make students understand this. Now you start by awarding the numbers from your right side to your left side. So award them with powers. Here is 0, 1, 2, 3, and 4. Yes. 0, 1, 2, 3, and 4. This one is in unit, raised to the power 0. There's no number, so 0. There's one number here. That's 1. 2 numbers, 3 numbers, 4 numbers. This is what is going to guide you. But when we are solving, we solve from left to the right. And when we are awarding the powers, we award them from right to left. And you know the place value, we start from the right to the left. So this is how we are going to solve it. So the first one, you take this one, 1 times, we are working with base 2, raised to the power 4, plus 0 times 2 raised to the power 3. The powers are used, plus 1 times 2 raised to the power 2, plus, so 1 times 2 raised to the power 4, 0 times 2 raised to the power 3, 1 times 2 raised to the power 2, then 1 times 2 raised to the power 1, plus 1 times 2 raised to the power 0. Yes. Now this will give us 1 times 2 raised to the power 4, powers of numbers, indices. At this juncture of my lesson, if you have watched my video on indices, this thing, it doesn't mean multiply the 2 by the 4. This means 2 times 2 times 2 times 2. Yes, 2 times 2 times 2 times 2. 2 to 4. 4 to 8. 8 to 16. So this will give me 16. Plus 0 times 2 raised to the power 3 will be 8. Plus 1 times 2 raised to the power 2 is 4. Plus 1 times 2 raised to the power 1 is 2. Then plus 1 times 1. Will you ask why? No. Because I've explained in indices and I've proven why any number raised to the power 0 is 1. So you need to understand and be careful here. Now what do we have here? 1 times 16 will give us 16, plus 0 times 8 is 0. Any number times 0 is 0. Plus 1 times 4 is 4. 1 times 2 is 2. 1 times 1 is 1. Now 16 plus 0 is 0. Plus 4 is 20. We have 22, 23. So the answer is going to give us 23 base 10. You can also write it 23. Yes, so we started with base 2. We were asked to convert to base 10. So our final answer should be in base 10. And what you have to understand is like logarithm. A log without a base is in base 10. Any number without a base is in base 10. We write all numbers in the decimal bases. So when it is converted, the base will be written. So you can write 23 or 23 base 10 or 23, and it is allowed. because we are working with a decimal number. So this is so easy and simple. Follow closely. Let's take the next question. So as the second question is posted, we have to convert 234 to base 5 to base 10. So we are converting from other bases all to base 10. So we are what powers here? 0, 1, 2, 3. So now to solve this, we are going to start from here. 2 times 5 power 3 plus 3 times 5 power 2 plus 4 times 5 power 1 plus 2 times 5 power 0. Now this will give us 2 times. Now 5 raised to the power 3 also means 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Then plus 3 times 5 raised to the power 2, which is 25, plus 4 times 5 here, plus 2 times 1. Yes, don't forget. So now 2 times 125 will give us 250, plus 3 times 25 will give us 75, plus 4 times 5, 20, then 2 times 1 is also giving us 2. Yes, so when we add 250 plus 75 plus 20 plus 2, it is going to give us 347, or 347, sorry, 347 or base 10. It's going to give us 347 base 10. So number base is very simple. Yes, very simple and easy to understand. So we are quickly going to take another question on this. So our next question, we are also to convert 2, 1, 2, 2 base 3, that one 2 to base 10. So let's award our powers 0, 1, 2, and 3. So to solve, we have 2 times 3 power 3. Then we have 1 times 3 power 2 plus 2 times 3 power 1 plus 2 times 3 power 0. Yes, so this will give us 2 times 3 raised to the power 3, 3, 3, 9, 9, 3, 27, plus 1 times 3 raised to the power 2 is 9, plus 2 times 3 raised to the power 3 is still 3, plus 2 times 1. Yes, now what do we have here? 2 times 27 is going to give us 54, plus 1 times 9, which will give us 9, 2 times 3, which will give us 6, 2 times 1, which will give us 2. Now when we add 54 plus 9 plus 6 plus 2, is going to give us 71 base 10 as our final answer. 71 base 10 as our final answer. So we are quickly going to take the next question. So the next question posted on the screen, 700 base 8. We are also converting it to base 10. So 0, 1, 2 here. So we have 7 times 8 power 2. 0 times 8 power 1. Then 0 times 8 power 0. Then here will give us 7 times 8. 8 is 64. Plus 0 times 8 plus 0 times 1. Yes. Now 7 multiplying 64. 7 times 64 will give us 448. Plus 0 here plus another 0. Yes. Plus another 0. So when we add this thing, we know it's going to give us 448 also in base 10. Also in base 10. So sometimes when you see the question on the screen, you can pause the video, you solve it, and check the solution to see if you get the correct answer. You know mathematics is constant practice. So let's take another question on this. So as the question is posted on the screen, we have to convert 341.25 base 6 to base 10. Yeah, don't be scared for seeing this decimal number. Yes. Now, what you have to understand is that in numbers, if we have this number, let me write this 0.486. Now, this decimal number, the place value of decimals, this one, the decimal separate the number into two parts. Yes, it separates it into two parts. So what you have to know is that this is our normal ones we know. This is tens, this is hundred, and this is thousand, and following. Now immediately you cross after the decimal, this one is tenth, is tenth. That is why when you see any number like 0.2, it means the number is 2 on what? 10, because of the place value. The place value of decimals is available on my channel. You can go and watch it and understand. So in the place value of decimals, we moved to the right. We moved from the right. Sorry, we moved from the left to the right. And non-decimal, we move from right to left. Yes. So this is ones, this is tens, this is hundred, this is thousand, 10,000, the one you know. But in the place value of decimals, what you have to understand is that after the decimal, the first number is tenth. This one is what? 100. This number is what? 1,000. Yes, this is 1,000. So this is what you have to understand. I'm explaining this because we are going to apply the same principle here. You need to understand. So when you see any number in decimal that you are converting to any base, you don't get confused. Yes, so I'm quickly going to move on. So since I've told you this is our normal there, so this is, you are going to award about 0, 1, 2. Now, I said this is 10. So we are going to award this number with what power? With what power? We don't know. So let me use 1. So if this is 0.1 and in decimal, I said maybe this number is 1 over 10. And I'm writing this one. This one is a decimal number. Yes, in decimal. This is decimal. This number is in decimal. The decimal number. The number in tens. So if I want to write this one as whole number, I'm going to write it 10 raised to the power negative 1. Yes, you remember. Writing the number as a whole number, fraction as whole number like this, it will be 10 negative 1. Now this one, because we are dealing in base 6, this one is going to be 10. This one, I'm going to award this one with negative 1. This one, negative 2. Negative 1, negative 2. Yes. Now, let's watch this. Now, we are going to solve this one in base 6. So, this one will be 3 times 6 power 2. 4 times 6 power 1 plus 1 times 6 power 0. Now, plus this one is going to give me 2 times 1 over 6. I'm working in base 6, not in the decimal base. If it is in decimal base, then me, I'm going to use 1 on 10 because this is 10th. Are you okay? So 1 on 6 power what? 1. Then plus 5 times, let me even claim this one. And this one also going to give me 5 times. This one is 10, this is 100. But because I'm working with bases, this one is going to give me 1 on 6 power what? 2. So this is the trick. Why do we say a number 2 on 10? To write it as decimal, 0.2, decimal, base 10. Yes, but when we are working in base 6, it changes. So this is what you have to understand. So when you go and meet any number with decimal, don't say you can't do it. That's why I'm explaining this. So if you're able to understand this, you can solve any number involving decimal that you are asked to convert to any base. And you get it on this channel. So now we are going to continue our calculation. Everything has become simple. So 3 times 6 raised to the power 2 is what? 36 plus 4 times 6 plus 1 times 1 plus, now this one, 2 times, I'm going to change, this one is 1 on 6, I'm going to change it in decimal. So 1 on 6, with the help of our calculator, 1 on 6, when you use your calculator in point 1 divided by 6, you get 0.1666666. Yes, you get 0.1666. So I'm going to convert it to 2 decimal place. So 2 times 0.167 plus 5 times 1 on 36. Okay, let me even make it step by step. I don't want to jump steps. So 1 on 6 here plus 5 times 1 on what? 36. Yes, I don't want to jump steps. I've told you when I'm teaching, I don't want to jump steps. So now let me multiply this two together. Or let me repeat this again. 3 times 36 plus 4 times 6 plus 1 times 1 plus, now when I come here 2 times, that's when I get 0.167. Yes, so with the GHS, when you can use long division to do it. With the SHS, you can use the calculator, you get 0.16666. Yes, but I'm going to leave it in 3 decimal place, 0.167. Then this one to give me 5 times 1 divided by 36. When you change it to, you are going to get 0.2777. 0.02777. So I'm going to write 0.028. Yes, in 3 decimal place and a roundable number of rounded. So now 3 times 37. When you multiply 3 by 37, you get 108. Then 4 times 6, 24. Then 1 times 1 is 1. Then plus 2 times 0.67. I'm going to get, I'll round it. So I'll write 0.33. Yes, 0.33. Then plus 5 times 0.028. I'll also round it. So I'll get 0.14. Yes, I'm leaving them in 2 decimal place. So you should pardon me and understand. So now when we add 108 plus 24 plus 1 plus 0.33 plus 0.14, we are going to get 133.47 base 10. So this is what we are going to. So the problem comes in when the number at the back of the decimal. So you use the place value of decimal, understanding that this is 10th, this is 100th. So because it's in base 6, that's why this thing happened. So I've explained, and I hope and I believe everyone will understand. So we are going to take our very last question on this part. So as I explained earlier, so this one will be the numbers here 0, 1, 2, 3, 4. And this one, don't think that the number here you count, so the powers is going to change. No. So the decimal has separated them, making them 2 different numbers. So this is the decimal part and the decimal part, and I've explained that. So this one, I've told you. Now, another way you can also understand this, this one, the place value starts from here. But when you are solving, we start from here with the power. And this one too, the place value starts from here. Yes, this one, the place value starts from here. So when you are checking how many numbers are at the back, yes, how many numbers are at the back, you have to be very careful to know that this is 10th. Yes, this is 10th, 100, 1,000, and 10,000. Yes, so this one, to know it, this one will be 1, 2, 3, and 4. Yes, 1, 2, 3, and 4. This is how we do it. So 10th, 100,000, 10th, 100,000, 10,000. Yes, 10,000. So now we are going to solve. So we have 1 times 2 power 4, 0 times 2 power 3, plus 1 times 2 power 2 plus 1 times 2 power 1 plus 0 times 2 power 0. Now plus 1 times 1 on 2 power 1 plus 0 times 1 on 2 power 2 plus 0 times 1 on 2 power 3 plus 1 times 1 on 2 power 4. Yes, 1 on 2 power 4. So we are going to make them simple here. So this one 1 times now 2 raised to the power 4. 2 to 4, 4 to 8, 8 to 16 plus 0 times 2 raised to the power 3 is 8 plus 1 times 4 plus 1 times 1 plus 0 times 1. In numbers of power 0 is 1 plus 1 times 1 on 2 plus 0 times 1 on 4 plus 0 times 1 on 8 plus 1 times 1 on 16. Yes. Now let's simplify this. 1 times 16, 16. 0 times 8 is 0. 1 times 4 is 4. 1 times 1 is 1 plus 1 times 0, 1 on 5. And we know, sorry, 1 times 1 on 2. And we know 1 on 2 is the same as 0.5. So, yes, 1 times 16 is 16, 0 times 0, 0 times 8 is 0, 1 times 4 is 4, 1 times 1 is 1, plus 0 times 1, yes, that's 0, plus 1 times 1 on 2. So, 1 on 2 in decimal is 0.5. So, 1 times 0.5 will give me 0.5, plus 0 times the number here will still give me 0, plus 0 times the number here will still also give me 0, plus 1 times 1 on 16. Yes, 1 times 1 on 16 is going to give me 0.0625. 0.0625. Yes, 0.0625. So you follow closely as we arrive at the answer. So you can add all these. Yes, and when you add all these together, all these, our answer is going to give us 21.5625. I'll leave it in 2 decimal place. 21.56 power 10. You can leave it in the digits or in words. And don't forget that these ones are the same as 0 times 2 raised to the power negative 2. Then plus 0 times 2 raised to the power negative 3. When you change it, the number, the inverse. And this brings us to the end of converting other numbers to base 10. And it has been simplified on this channel. Playlist will be created for this topic as well. So when you need it and you go to the playlist on number basis, you see all the lessons there. And there are short videos that are past questions I've selected on my channel. So when you click on short, you see that. Until we meet again, this is your Busy Made It Easy channel, the best math channel in the world, and the only channel we make mathematics fun. Don't forget to subscribe and share for everyone on TikTok, on Facebook, and here as well. So goodbye and watch out for the next lesson.